Dr. Bruuselma dirige des recherches et des programmes d'éducation pour la région du nord-est de l'Amérique du Nord. Il travaille pour la International Plant Nutrition Institute. C'est un organisme scientifique à but non lucratif qui est responsable de la gestion de la nutrition des végétaux. Dr. Bruuselma est aussi membre de la Société canadienne d'agronomie, de la Société américaine d'agronomie, ainsi que de la Société américaine de la science du sol, en plus d'être conseiller certifié en grande culture. Il cumule une vaste expérience comme chercheur en sciences du sol, notamment il travaille avec la Cornell University, l'Université du Minnesota, et aussi en agronomie avec le Mennonite Central Committee qui est au Bangladesh. Alors, Tom, I give you the floor for the next 35 minutes.
Merci beaucoup, Athena. Sometimes I can almost ask permission to, to speak English in French, but it is very difficult for me to speak French in a speaking situation like this, so I will have to speak in English. I want to thank the people who invited me here, particularly Nicolas, for the idea of this. It is certainly an honor for me to speak with Dr. Peter Kavariga and Dr. Jim Scheppers as well, who I've become acquainted with both yesterday and in previous times. I'm also pleased to see a few familiar faces in the audience, and also very pleased to see some younger and new faces that of people I hope to meet in the next day or two here as well. So the title, Nicolas actually suggested to me a number of titles, which will seem a little bit eclectic, quite a collection of topics, but I think I can try to put them all together. I chose the title of Bringing Better Practices to the Farm, which is essentially what our institute is all about. The International Plant Nutrition Institute is a scientific research and education organization that is supported by producers of fertilizers worldwide. Approximately 30 people like myself work in various countries around the world, and our aim is to help communicate scientific information to the industry, to the people who sell fertilizer products around the world. As an outline for today, I will talk a little bit about our global framework through which we speak about fertilizer management practices, the 4R nutrient stewardship concept and how it relates to sustainability. Then I'll talk a little bit about adaptive management, and I think Peter has provided us some really good examples of data and how data collected through adaptive management can improve farmers' management. Then I will talk about just data itself and how we're managing data and questions about that and how we're interpreting data through new techniques. And then I will talk a little bit as well about some recent experiences in bringing better practices to the agriculture of the Lake Erie watershed, particularly in relation to the increasing frequency of algal blooms in Lake Erie. And I know that phosphorus is a topic that has certainly been front and center in Quebec for a long time as well. If for any details that you may see that are going by too quickly, I have posted my slides at the URL indicated here, which I will repeat at the end of the presentation as well. Peter mentioned the 4R concept, applying the right source at the right rate, the right time, the right place. We use that because we can use it to describe any nutrient application in any situation. And what the key word then becomes right. Sorry. And in our definition is a very, very simple definition as what is right. What is right is more sustainable. Of course, that just transfers the definition problem a little further down the line. It means we have to agree on what is sustainable as well. But we are getting closer and closer to definitions of sustainability. There are internationally accepted standards, and they usually involve multiple stakeholders, everyone impacted by the system within which we are working. When we apply nutrients in agriculture, we were working within a cropping system. That cropping system itself has benefits for society, economic, environmental, and social benefits of any practice. We can also have detriments if we manage them wrongly. So our focus has been increasingly on participating in various sustainability initiatives. I've shown here 3 examples: the Field to Market initiative in the United States, which you may or may not have heard of, but they have a website presence as well. The Sustainability Consortium. And then I put here an example as well, Walmart, and Walmart particularly because they singled out for their ecological footprint the importance of fertilizers. And so as an industry, we are seeing it increasingly important to be engaging stakeholders. Each of these initiatives is usually a collaboration of people in agriculture, various parts of the agricultural industry, along with consumer organizations, environmental organizations as well, because it is essentially the sustainability of the earth for future generations of humanity, and we're all working together towards the same thing. We are recognizing increasingly the need to have performance indicators that reflect our progress in sustainability. They need to reflect a balance of social, economic, and environmental aspects of performance. We recognize that most of these indicators, they're indicators of the performance of the cropping system because we apply nutrients to enhance that performance. And so they're influenced by crop management and soil management as well. We also recognize that we need to respect stakeholder priorities and allow them to choose the performance indicators and report to them. But we also, at the same time, have a role in educating stakeholders as to how we influence those performance indicators. One of the indicators I like to work with, and will work well probably with you who are in the audience today because we are all acquainted with agronomy and we like to see detail. I like to work with crop nutrient balances, inputs and outputs, because that is the heart and soul of what we do. But of course, interpreting this kind of information is probably too complex for a lot of the people that we need to communicate to as well when we're communicating to all of society. This indicates, I have lumped together here the provinces of Eastern Canada, Ontario, Quebec, and the Atlantic provinces. I use Statistics Canada data mostly. The blue indicates the fertilizer sales for nitrogen. The green is our estimate of nitrogen fixation. It's a very simple assumption that we make. We assume that soybeans fix their own nitrogen, so everything the soybean crop removes was provided by fixation. Everything the alfalfa crop removes was provided by fixation, and all the other crops have no fixation. It's a very simplistic assumption, but still for this purpose, it's at least gives us a ballpark estimate. And then I have the manure divided up into 2 categories: recoverable manure and non-recoverable manure. These are definitions used by the Natural Resource Conservation Service in the United States. They reflect the manure that is collectible from farms rather than deposited on pastures. And it adjusts for losses. And of course, with nitrogen, there are multiple losses from the time the manure is dropped in the barn to the time it's applied in the field. And so the actual recoverable amount of manures is fairly small. If we just took fixation and fertilizer into account, we would almost think we were in balance, but we recognize that a great deal of this nitrogen does get applied to fields, and even some of the losses from the barn in terms of ammonia volatilization, that again is deposited on fields as well. So we recognize our efficiency is not perfect. We have much room to improve. As yields and production increase, we see increasing removal. Some of the increases in nutrient applications match that increasing removal. So there are a lot of good messages that can be put in, supported by these kind of data. The other thing is, we've already mentioned a little bit about weather and its impact on crop production. shows up right here because we have year-to-year variability. A lot of our agriculture, or a lot of our crop production depends on the weather in terms of its productivity. And when we look at the phosphorus balance, an interesting story here. Large surpluses in the past, in the 1970s, the 1980s, there was a philosophy of build up the soil fertility because phosphorus is retained in soils. And then as the soil fertility built up, application rates began to go down to the point where we were almost in a deficit situation for phosphorus. And then corn prices rose to $8 per bushel or higher. And farmers felt, apparently, that increased rates of phosphate were justified again. I can't fully justify it on an agronomic basis, but certainly rates in the last few years seem to have gone higher. These, I should mention, are based on Statistics Canada data for shipments to agriculture market, and they are actually conducted at the wholesale level, not sales to farmers. So I'm not always sure that the variations from year to year are actually appropriate here. But at the same time, the bulk volume of fertilizer should be fairly accurate. Potassium is a different nutrient, is one that has been applied in amounts less than crop removal for a considerable period of time in eastern Canada. So Ontario, Quebec, very similar patterns. If you look at Atlantic Canada separately, it looks quite a bit different from these patterns because it's very much dominated by potato. Another indicator that is important to keep in mind, because when we look at indicators in our industry, we need to reflect the effectiveness of our nutrients, the effectiveness in increasing crop yields. We need to look at efficiency, but at the same time, we also need to look at what is happening to soil reserves. And our institute, every 5 years or so in North America, we conduct a survey of soil testing laboratories to indicate what is happening to soil test phosphorus, what is happening to soil test potassium. And here we have 3 separate surveys, 2001, 2005, 2010, across eastern Canada, looking at the frequency of soils testing in these different categories that we convert to a Bray P1 equivalent, roughly the same as a colorimetric MELIC test for MELIC 3 phosphorus test for those who are interested in the technical details. Usually critical levels fall somewhere between, on this scale, somewhere between 20 to 30. And you can see that it's a fairly small fraction of soils, not the majority of soils, that are deficient in phosphorus in eastern Canada. And there's a large fraction of soils that probably test higher than they need to test, owing to the fact that we are a livestock-intensive agriculture in most of eastern Canada. And that history shows up in the soil tests here. If we look at potassium, a very different distribution. Most critical levels are around 120 parts per million, so the cutting line would be here, and we see almost half of our soils are deficient in potassium. And not only that, but over this 9-year period, the frequency of soils testing deficient in potassium has been increasing. So we are due to do another one of these surveys probably in the year 2015. So those are some technical indicators, and you can relate them to both the economic and environmental impacts of nutrient use. We also need to deal with the social impact if we are truly going to engage the sustainability issue. And from a scientific point of view, that one was very difficult for me, but I found that when it comes to agri-retailers, they usually have a very good handle on this. Most of our industry recognizes the importance of the idea of social license to operate, the idea of having the goodwill of neighbors, and having the goodwill of the consumers of our products. So I wrote a small article on it in these few points, and it was received fairly well. The impact in the social area is certainly not as direct as it is on the economic and environmental. There is an easy one, placement of manure and odor, of course. There's a social issue that can very easily be addressed. If we place our manure in the soil, we have less odor, obviously society will look upon that as a positive. More profound impacts, when we use this concept, we are working towards sustainable intensification, producing more food on less land, sparing land for nature, and we can also look at, as we intensify, we require more minds, we require more advice on how to use the tools, decision support for technologies, for more precision agriculture. Those too are social benefits in terms of employment opportunities. Precision agriculture, again, relates to that. Intensive approaches on extensive areas. And we need to improve our accountability and communication. That too, again, is a social benefit. If we get more of the population of Canada, the population of North America, to understand what we do in agriculture, what we do in plant nutrition, that is an important benefit as well. And then there is the concept of maintaining soils, their productivity, their fertility for future generations. That too is a social benefit. Sustainability, my main points are the 4R framework is essentially for communication to enhance public understanding of nutrient management. Our performance indicators, we are working as an industry to select and develop performance indicators. And if you see sustainability reports of various companies, various countries, you'll see that they put a lot of emphasis on choosing the right indicators. We need to reflect the effectiveness of nutrients, we need to reflect the efficiency with which we use nutrients, and ensure we cover the economic, environmental, and social dimensions. And important as well is that we have a global approach. A lot of the work on sustainability takes place at the global level. We have put a lot of emphasis in participating in the United Nations Sustainable Development Solutions Network, where they are proposing 100 different indicators to address the sustainability development goals that go past the year 2015. Goals of reducing world hunger, goals of reducing waste, improving efficiency, reducing environmental impact, and ensuring that our planet has a sustainable future. It includes the planetary boundaries concept, in fact. Now I want to talk a little bit about adaptive management. We include this in the 4R concept, and this diagram I intend to show that, as Peter noted, you can use post-harvest analysis, evaluation of outcome in terms of the performance of your cropping system. Sometimes the indicator may be a cornstalk nitrate test. Sometimes the indicator may be an aerial photo showing where deficiencies were encountered. Farmer keeping records of yields and nutrients applied. That's all part of a decision cycle that takes place on the farm. And what needs to be considered in there are the same performance indicators that are used at the higher levels, the global level. The global level needs to influence the farm cycle level. We as agronomic scientists, as extension workers, crop advisors, need to be considering the same decision cycle as well, and developing decision support. And then you can also say there's a higher level yet, a policy level, at which governments work, and perhaps some of the larger companies in the industry also work. They make decisions as to what infrastructure is available to support all of these decision cycles. So adaptive management is a core component of the 4R plant nutrient management system. One of my favorite topics is adapting management to weather, particularly nitrogen management. And Nicolas has been a past supporter, was a participant in the symposium we held in 2006. Today we have systems like these. A farmer could purchase for less than $2,000 a system which can continuously monitor the weather and every 5 minutes report temperature, rainfall, and more to the internet. Post it on the internet, make that data totally accessible to farmers, and yet most of us working with crop growth models, soil models, and those sorts of things, we're often working with models that still have a daily time step. There's a huge opportunity here to develop more tools, more sophisticated tools that will truly adapt to nitrogen management. Forecasted weather. We often say, well, to improve nitrogen management, we have to be able to deal with the weather better, but we can't forecast the weather, so we can't do anything. Well, that is, I don't think that's true. If you look at a lot of meteorologists, they are showing that they are increasing their forecasting ability, the forecasting skill. And if we can use this with a probability-based approach, we can, I think, improve nitrogen use efficiency. These are some recent data from a project IP&I supports in Ontario, and I just wanted to highlight this. I don't know that I can generalize to say these data prove my case, but these are nitrogen response curves from a trial in Elora, Ontario, which is a very short season growing area, but very nice soil as well. We have the years 2009 to 2013. And fitted response curves. The data supporting these are 5 different rates, beginning at 30 kilograms per hectare and going up to 260 kilograms per hectare. You can see here 5 different years, only 2 had similar response curves. 2012, of course, was a drought year, so as expected, in a drought year, yields are reduced, most economic rate of nitrogen was reduced, but nitrogen was still very important to overcome drought stress. 2013, following the drought year, going into the spring, right into June, we had dry conditions. We normally expect after a dry year, large amounts of mineralization, possibly some residual mineral nitrogen in the soil. And right up to June, it looked very consistent. There seemed to be no visible response in the trial. Late June, early July in 2013, we had large amounts of rainfall, and in the fall we had a very good final part of the season. Corn took advantage of that, very high yield potential, very high optimum rate of nitrogen to apply. Some of this is still a tremendous challenge for us to try and predict and handle, but there is a large amount of variability here that we need to be focused on addressing. The current Ontario recommendation system addresses some variability, but it does not address year-to-year variability. If we use a pre-sidedress nitrate test or sensors, we can address part of year-to-year variability, but not the whole thing. We need a comprehensive approach that is based on models that integrate all the factors involved in crop demand for nitrogen, soil supply of nitrogen by mineralization, and potential losses from the soil by the various mechanisms through which nitrogen is lost. So this is basically my summary slide here, decision support for adapting nitrogen management to weather. Different soils will respond differently to weather. Because of the complexity, we need a decision support system. But the important thing about these systems is that they can't just be a black box. Farmers and managers and advisors will not trust a black box. They will need to understand how it works. They won't need to understand all the details, but at least some of the details as to how it works. So we not only need to develop these models, we need to explain them, educate, and we can do that with various tools that with the computer technology we have nowadays, we can make models come alive. We also need to field test them to a much greater extent than we've ever thought before. A lot of modelers will work with models and run a few field tests and say it's validated. But if our objective is to engage the model and solve this problem of year-to-year variability in nitrogen, then we need to do probably thousands of field validation trials before we can truly improve it and integrate it into the system. I wanted to put this in as well, as that genetic change over time. This was published over 15 years ago, comparing old and new hybrids, and since then we've probably developed more new hybrids. Corn clearly, as it's genetically improved for yield, requires more nitrogen uptake in the end of the season, whereas older hybrids used to take up most of their nitrogen by the time of anthesis, by the time of tasseling. That's not the case any longer. So we need on-farm research, we need transparent models that can be understood, and we need to understand the new hybrids as well. A few comments on data, and I'm not a tremendous expert here. I have more questions here than answers. But I wanted to point out one example in Australia where they've established a website. This took several $1 million in funding, but they took all the old data they could for crop response to nutrients. And they call this Better Fertilizer Decisions for Crops in Australia. What it looks like is a interactive website where you can choose the nutrient, you can choose years, states, locations, farming systems, you can choose crops, and you choose soil types. And once you have done that, it will deliver to you the data and allow you to manipulate it the way you want. So you can query a database, ask specific questions, and quantify, get a quantified answer essentially to your questions. How much yield will I reduce if I cut back on fertilizer? How much yield increase will I expect? And environmental data could be stored in this kind of database as well. We have a lot of data. It would take a huge amount of effort to make it this accessible, but I'm quite familiar with a lot of data in Ontario, and I understand from Nicola that a very similar project is in the works here as well, and I encourage that. In the healthcare industry, meta-analysis and systematic reviews are very popular these days. And can we match the caliber of rigor that is being applied for these kind of reviews in the healthcare world? Evidence-based nutrient management is essentially the goal we are striving towards. And one example here is the Cochrane collaboration. If you want to have a health question, they have assembled their data and their reviews so that you can ask specific questions. Anyone from the general public can ask specific questions and get a synthesis of literature supporting various answers to questions related to human health. It does raise some challenges. I do see in our agronomic literature an increasing number of quasi-systematic reviews that go beyond the traditional literature review, which was simply a list of publications, who's done work on what, but at the same time aren't fully systematic reviews. And there is potential for making erroneous conclusions if you are only looking at part of the literature and not being fully systematic and stating precisely what selection criteria you have for the studies you are including. And then there's a huge number of hypotheses to test, so there's a lot of work to be done on systematic reviews. Meta-analysis is another tool that I have been encouraged to explore by Dr. Léon-Étienne Parent, and I think it is a very interesting area. We have examples of some work that Nicolas published with other scientists of corn responses across North America, and having learned something about weather conditions during particular periods of growth in corn and how they might relate to the probability or magnitude of responses to expect. Meta-analysis as well has challenges. You know, I have been exploring the Borenstein textbook, but it raises a lot of questions as well. One big question I have is when you review published studies, one of the criteria for publishing a study is that it's original and different from anything that has been published before. So it's often very hard to choose a group of studies that are all addressing the same objective. But at the same time, I think there is opportunity. There is probably even a greater opportunity for we as agronomists to take the data that we have been collecting to support various soil calibration studies, because a lot of that data has gone unpublished, and meta-analysis may be a very good tool to analyze much of that data. Questions of grouping, how you do the grouping, whether response ratios are the best tool to use, and the use of log transformations are all questions that I have that may depend on the particular aspects being studied as to whether they are appropriate to use. So in terms of data, we as an industry are working to support data curation, greater accessibility to the data that support nutrient recommendations. We're working to support and fund systematic reviews and meta-analysis of data as well. There is a big opportunity, I believe, to network across political jurisdictions, and so that we integrate, for example, corn in Ontario, corn in Quebec. This would be a good thing and good opportunity to refine our recommendations. Finally, how many minutes do I have left? 5 minutes? Okay, thank you. Now I'll make a few comments on the Lake Erie watershed. IP&I has been engaging this issue for the last couple of years. I have on the table behind you, there is a number of handouts that relate to specifically the Lake Erie phosphorus issue. Essentially, we are engaging for our nutrient stewardship approach, and the big difference of the Lake Erie watershed versus Quebec and in Ontario, when phosphorus issues arose in Ontario and Quebec 15 years ago, our main approach was to deal with responsible management of manure. But when we look at the Lake Erie watershed, manure is a fairly small component of the whole thing. That shows up right here. The manure is on the bottom here. This is the fertilizer phosphorus in the state of Ohio. You can see that while we've made improvements in phosphorus in terms of the balance of applied versus removed by crops, that the bulk of the phosphorus applied in the watershed is indeed fertilizer. And so a lot more may relate to fertilizer management practices. There's also, and I don't have a lot of data to support it, but there is, if you ask any dealer, the frequency of broadcasting relative to banding is increasing. Farmers are getting larger planters. Fewer of them are putting phosphorus down in the band, and this is leading to more broadcasting. Broadcast phosphorus plowed into the soil is probably not much of a problem. But another thing that is increasing in frequency is either no-till or conservation tillage. So a lot of that broadcast phosphorus is staying near the top of the soil. And we know from runoff studies that if you increase the soil test phosphorus level of the top inch of soil, that's the part that affects the concentration in the runoff. If you have actual phosphorus fertilizer lying on the soil surface, well, yes, phosphorus does stick to soil, it is retained in soil, but the phosphorus fertilizer we are applying to soil is soluble phosphorus. And if we have a rain runoff event as the first thing that happens after we apply phosphorus fertilizer, it will only lose no more than 10% of the fertilizer, but it's a problem for Lake Erie. And so these are the messages we have been getting out with the right place message for our nutrient stewardship. These data simply show that Ohio has a very different soil test phosphorus distribution than Ontario or Quebec, far less in the high end. It's not an overall rate question. The critical thing that people need to be paying attention to is timing and placement of phosphate fertilizer. And so we've been looking at combinations of source, rate, time, and place, looking at the practices that farmers are already using, and then looking at alternative practices and comparing their advantages and limitations. There are some good reasons why farmers are broadcasting phosphorus in the Lake Erie watershed. The heavy clay soils have a very narrow window for time of planting. Planting needs to be done rapidly, and if fertilizer is slowing people down, that may be reducing their yields. So these are things we are trying to work with growers with, work with the dealers with as well. In response to the issue, a number of growers have developed a 4R nutrient certification standard. This is nothing, IP&I does not necessarily support going to certification standards. We have developed the concept as an educational tool, but there are areas in which it's seen as necessary to develop a certification standard. For example, a very simple rule in the Lake Erie watershed: don't apply phosphorus on frozen soils. Even that simple rule is very difficult for an agri-retailer to adhere to, because he knows if he says no to a farmer who asks for it, the farmer will go to another dealer down the road. This gives them a reason to say, well, no, I'm a 4R certified dealer. I cannot apply phosphorus on your frozen soil. And you can go to the dealer down the road because he's not 4R certified. So there's this distinction made. And so far, it's only going to be a designation. There's no financial reward to it. In fact, it's a financial cost. Who are the people who put this together? This began as an initiative with some of the retailers. The Andersons are located in Maumee, Ohio, right on the Maumee River. Morale Companies, Deschler Farmers Elevator has since changed, restructured and become Legacy Farmers Co-op, and there's a Farmers Elevator. So these are the three primary ag retailers who were involved. They engaged the Nature Conservancy and other organizations, as well as some government organizations, to form a partnership and develop this for our certification. This was launched just last month in a town near Toledo, Ohio. They had more than 190 ag retailers in attendance. 22 of them so far have signed up for an audit this summer. Failed to point out the basics of the standard are training and ongoing education, so that they need to have some training in the program. They need to have people who are certified professionals, either certified crop advisors or other professionals involved. They need to monitor implementation. That means record keeping. And they are required to keep records of every customer they sell to. They are required to keep records of every recommendation they provide. And then the recommendations and any custom application they do have to follow guidelines. And the guidelines are stipulated in this document, and had input from all those that were involved. So the summary of my talk then, I guess, is that what I see as important is that sustainability performance indicators, engaging stakeholders is very important, and that's what our industry is doing. I see important as that we get involved in adaptive management and on-farm research to improve both the effectiveness and efficiency of nutrient use. We need to make the data that support nutrient recommendations more accessible to achieve both number 1 and number 2 there. And that certification, professional recognition are important as well. I want to thank you very much for your attention. I will point out again the materials I have on the back table, and the website that I maintain for the northeastern part of North America. The URL is here. Any of you engaged in teaching may want to explore our plant nutrition manual as a tool to be used in education. Thank you.
Thank you very much, Tom, for this very interesting talk. We have time for questions.
So, Tom, thank you very much for your presentation. I remember a slide that you showed up, the one on hybrids. Mm-hmm. The fact that apparently they do require higher level, they do uptake higher amounts of nitrogen. So there was a discussion going on among a few of us last couple of months whether or not this slide was true. And not actually this slide, but this idea of new hybrids requiring higher levels of nitrogen. So my question is, are you quite positive about that, or is there still room for new data to establish this difference with new hybrids? And the other question is, does that mean higher fertilizer requirements if they do uptake more?
That's an excellent question, especially the last one there, because I did not mean to imply higher fertilizer requirements, that's for sure. What these data are showing, and this was comparing the Pride 5 variety released in 1959 in Ontario with the Pioneer 3902 released in '88, and I'm pretty sure this one will have been extinct by now. The data, so my comments are these are measured data. These were measured in field plots. Tice Tolinar's grand challenge question was always, what physiological characteristics are changing in hybrids that support higher yields, comparing old hybrids and new. And so the nitrogen actually ties into a characteristic that he did establish, and it was related to stress tolerance, it was related to the tolerance of higher plant densities, and a lot was related as well to the plant's capability to continue growing in balance between source and sink, ensuring that the continued growth all went into the cob. It's related, if you look at new hybrids compared to old hybrids, you will find that there is more of the stay green nature. The leaves stay green later. They continue photosynthesizing and providing photosynthate for the filling of kernels right up to physiological maturity. Because they are stay green, they need to maintain most of the protein in their leaves to support photosynthesis rather than exporting the protein from their leaves into the kernel. So we don't have self-destruct mechanism anymore. So that requires continued nitrogen uptake. Now when we go to the new hybrids, including the one I showed you in those 5 response curves, that was a triple stack hybrid, BT, rootworm resistance, and that seems to confer a longer lasting root system as well. So, and then if you look at the nutrient use efficiency of corn over the past 3 decades or so in general, what you see is that nitrogen rates have remained the same as farmers have increased the yields of corn. And so you ask yourself, where is that coming from? Well, you know, mineralization of the organic pool in soil is usually proportional to temperature. Soils remain warm well into August, September, and even perhaps October. They continue to mineralize nitrogen. That late season mineralized nitrogen was wasted on corn that was a self-destruct mechanism. But it is available to corn that is continuing to take up nitrogen later on. So this need for nitrogen after silking, a lot of it may be met by mineralization from the soil. You can't always assume that that is enough, but the nitrogen needs to be there, and that's critical for the yields of these hybrids as well. Does that address most of the question that you had?
Yes, absolutely. Just another comment is the fact that I reached out to people I know in Pioneer in Iowa, and I asked them whether or not there was a higher requirements for nitrogen for some hybrids, and they were a bit balanced opinion. As well, there are some indications, but we're not sure, and so it was not so clear that new hybrids were automatically requiring higher fertilizer application for sure. But as well, there was this trend for new hybrids to have a higher uptake, as you just mentioned. And then we have had trials by a colleague of mine, Gilles Tremblay, here, who has kind of tend to indicate that yes, there was some higher requirements for nitrogen for those in the recent years, let's say. So Gilles is here. Maybe you'd like to comment on that, but anyway. So that's it. Any other question? Question?
Yeah.
I have a question about weather, which is an elusive concept, and I'm wondering what data do you use? Do you aggregate data? Do you use indices or raw data in the concept of weather? And where do you get these data? From the farmers, from the regional organization, or?
You raised some very good questions. You know, what are the critical things to measure in terms of weather? In terms of the mechanistic understanding of what happens to nitrogen in soils, it's all related to water. So I would say number one is the rainfall is the most important. And then of course, the timing of that rainfall can be very important because the timing of the processes and the timing of the uptake of by plants, the timing of susceptibility to loss.
Well,
And Now, while I'm supportive of the concept, I can't say I have a whole lot of projects that look very closely at that. We have been collecting data from the experiment I showed you in Elora, and we're at the stage where we're beginning to apply models to that. The experience I had from 20 years ago during my Ph.D., I was looking at application of models to see how much improvement we could get in terms of the relationship of various parameters. And one experiment was to look at their database for the relationship of corn yield response to the pre-sidedress nitrate test. And I tried a number of approaches. One was simply taking the sum of rainfall from April 1 to the date of the soil nitrate test and see whether that could provide an adjustment factor for the test. And it worked in terms of a regression approach. It was statistically significant, but it was a small impact, probably not enough to improve the predictive power, substantially enough to justify an extension effort. I tried more sophisticated approaches using models, and the results were less promising. But it's quite possible that the models were not quite right. And getting just the right model is very important, because models, the more complex you make them, the more artifacts they can introduce as well. So it takes a lot of rigorous thinking, testing, and a cycle of adaptive research to really address the question that you've asked here. Yeah.
Yes, the problem we will have millions of data from Environment Canada. And
yes.
How do you synthesize this in very simple concept and make groups like in multi-levels or in meta-analysis? This is the challenge for us.
That would be the critical question. I would encourage us to be as mechanistic in our thinking as we can be.
Hello, Marc-Olivier Gasser de l'IRDA, Québec.
Okay.
I have a question regarding, we can adjust for lower levels of nitrogen needs when we see we see some indications that the soil will give more nitrogen, or the corn stalks deliver us a good indication that nitrogen levels are high enough that we can reduce nitrogen levels. But in some cases, we can see that we need to add more nitrogen in case in maybe a rainy weather, or in some cases we need to adjust higher levels to obtain the yields we would like. In some cases, the crop response will be that you can have maybe a linear response up to maybe 250, 300 kilos of nitrogen, and then the question raises, how can you sustain high levels of nitrogen applied and at the same time address environmental issues when you're producing maybe the different yields? Maybe you produce 5 tons, maybe you produce 15 tons. So the N uptake or the efficiency is not the same.
Yeah.
So you have to put sometimes a limit. And how do you address it? How do you fix these limits? Normal experts usually fix it by their own, but at the same time, we should be honest and tell the stakeholders that you could have a response up to 250 or 300 kilos of nitrogen, but it wouldn't be environmentally sane. Mm-hmm. So we have to fix these limits. How do we fix these limits and ensure that all the stakeholders are up to this or know the...
This is a very good question. I noted the same thing in Peter's data as well. The generalization, wetter years, corn needs more nitrogen. But the corollary to that is that wetter years are also more likely to have larger amounts of leaching. The way we can address that, there are a couple of options. One would be to set target levels of nutrient use efficiency, as you mentioned. And if we're able to make the predictions, then we can, instead of going to the 250 level, we can increase, but maybe to a more modest level that will get us a target level of nutrient use efficiency, as well as perhaps minimize the concentration in runoff. The other thing is, if the issue is a concentration issue, large volumes of rain may help us through dilution. And that's another way we could develop a predictive tool to say what is the acceptable diluted concentration in this high rainfall situation. But the key point, though, I think we need to we shouldn't be losing sight of the fact that we need to support good crop production. If we have reliable high yields, we will spare more land for nature, and in sum total, the losses and damage to the environment will be minimized when we do that.
So that's all the time we have for questions. So we're going to pass to our next conference. Thank you very much.